I think we're live. Hey, this is Toby. This is a walkthrough of the LLVM tutorial. I did some intro in the last video. This video we're gonna dive straight into it, into the first chapter. There's gonna be some software that you need to install. If you don't, I'm on a Mac, but I think this can be done on Linux and Windows as well. But in any case, you're gonna need a C compiler to start this. Now, LLVM project itself provides a C compiler, and it's possible to use that. However, if you're on a Mac, it's pretty convenient and recommended to install either the command line tools, which you can find instructions on how to do that here, or you can install Xcode, which is their development environment, which is a much larger install. But if you are interested in developing for the Apple platform, this is recommended. I have just the command line tools installed myself. I don't care to install Xcode. It's a very, very large package, and I personally don't use it. To check whether you have what you need, you can type GCC and see if that exists. If it says Clang or something, it doesn't have to be Clang, but if it says error, no input files, that means you have GCC. The program we're gonna use to compile our C++ code is actually called G++. So you can check for G++ as well. Yeah, with that, let's get started. So did I make a new directory? No, I did not. I'm gonna make a new directory called LLVM first lang. You can call it whatever you want. And then I'm gonna use Code Insider as my text editor, and it doesn't matter too much which one you use. One thing about this tutorial is a guided tutorial. All of the code that you need to write is supplied to you. However, it does expect some level of proficiency with C++. But if you're following along with me, hopefully you can get by with just very little knowledge there. As I go, I will explain the C++ constructs, just in case you are not that knowledgeable about C++, but just are interested in what we're doing here. Okay, so the first thing we're going to do is to create a Lexer. I'm going to make a file, and I'm gonna, let's call this, I'll just call it mylang, and I'll suffix this file with .cc. Some people like to use .cpp for C++ programs. Some people like to call it .cc. I'm gonna use .cc because it's shorter. And I'll just type in what the tutorial has me type in. What's a Lexer, first of all? A Lexer is a preprocessor in a parser that will separate a string of inputs into chunks. So for example, this program here, this is going to be the program, and it's got a lot of different types of things. It's got comments, it's got this def keyword, it's got an if keyword, and it's got this function name, etc. What a tokenizer is responsible for is to sort of pick out the important chunks, like, oh, that's a def keyword, that's a chunk, and then that's a function name, that's a chunk, and then this open paren is a chunk by itself, and then this X is another identifier, that's a chunk. So it's gonna sort of split the string up into these chunks and give each chunk a type. Like, for example, it'll give this type it's the type of the def keyword, and the fib is the type of identifier, and so forth. Okay, so the first thing that we're doing in this tutorial is defining the different types of chunks, which are called tokens. Different types of tokens that we can have in this programming language, and here they are. We have enough file tokens. We have the def keyword, that's this guy. We have a extern keyword, which I think it's like this keyword extern here. Identifiers are like either function names or variable names. We also have numbers. Apparently in this programming language called Kaleidoscope, the only values are floating point, 64-bit floating point numbers. There aren't strings in this language, which makes it kind of limited, but you know, this is a tutorial, right? Okay, so we're gonna make an enum, which is gonna list out all the different types of tokens we have in this language. So let's do that. I'm just gonna copy this code. And we need a semicolon here. Okay, so this enum, in reality, it's really just represented using an integer. And this feature here where we explicitly set the integer number for each enum mode, it's a feature of C++. The reason the author is doing this is because it wants to use this enum type to double as the characters in the event that the token doesn't fit any of these prescribed types, which if you ask me, that's a really weird way to do it, but you know, let's just follow along. We're gonna define two global variables actually, which is the first unsavory practice instance of unsavory practice that we've seen. But basically whenever the parser or the Lexer discovers an identifier string, it's gonna save it into this string variable, and whenever it identifies a number, it's gonna save it in this numVal variable. Let's just not question it too much. Let's just follow along. Okay. In order to use the string type, you need to include the the string library from C++. The author of this tutorial didn't think to mention it, I think, because they probably thought that was obvious to any C++ developer. Which I agree that should be obvious if you know C++. Okay, now we're gonna write this function called short for get token, obviously. I think it's intended to be a function where if you call it, and it'll parse the stream of strings, or parse the characters in the string until it grabs enough characters to recognize a single token, and then it'll return that token, and a token can be represented using an int, because int can represent either one of the enums that are listed here, or it can represent just a character, a single character, which they say unknown character. In reality, it's not necessarily meant to represent unknown character. It's meant to represent known characters as well. But anyway, I'll talk through how this thing works as we go. I don't like the fact that he doesn't use block. He doesn't use these curly brackets to denote a block. So I'm gonna put those in myself. That's kind of a pet peeve of mine. Okay. So what is this code doing? Well, there's a last char. I don't know why we initialize it to a empty space, but basically it's saying while the last char is a empty space, we're gonna read a character from the input. The get char is a function in standard C library, I think. That's gonna read one character from the standard input, which is actually when the user is typing in some text and hits enter, that text goes into the standard input. So it's actually reading what you're typing in, but get char reads just one character. Okay, so it's gonna read one character that you typed in, but it could also be coming from the file if you took a file and piped it into this to the standard input of this program. So it's basically reach one character, and then stores it, and then it loops. And basically, if the character that was just read is a space, it's gonna read another character. It's gonna keep reading characters until it gets a character that's not a space. So in essence, it skips spaces. Yeah, it skips all spaces. That's what that does. I think this paragraph explains as much. Let's keep going. I think this code here recognizes a identifier, and an identifier it uses the normal C programming language, and also JavaScript uses this as well. This is a standard identifier rule in programming languages. Is the first character of an identifier is a letter, and then the rest of the characters are either letters or digits, right? So I can have name is a valid identifier, name1, name2 are also valid identifiers based on this rule, and this is what we're trying to match with this code. So let's type this in. Whoa. How did we get this thing, this spotlight thing? I did not mean to get that. That was from my drawing program, I think. Okay. So is alpha means, is it an alphabet character? So this line here actually converts this character, which is represented as an int in here, but it converts it into a string because identifier string is declared as a string. This line actually coerces this integer into a string, which is kind of unexpected, but C++ does that. I guess JavaScript does that too. JavaScript will happily coerce an integer into a string, although JavaScript will actually convert the number into the string representation of that number, whereas this one actually interprets this character as a character based on this number as an ASCII code. Okay. Now, okay, so it read the first letter, which was this one of the identifier, and then while the next letter is alphanumeric, we're gonna keep reading characters from the input stream. I'm gonna put in my block, even though the tutorial doesn't have that, and then we're just gonna character to the end of this identifier string. Now, if the identifier string happens to be one of the two keywords we have in this language, and those are def and extern, then we're gonna return it as a token of that corresponding type. Otherwise, we're gonna return the identifier token type. And while make the identifier string available in this global variable here for parts of the program that need to get that string. Okay, so yeah, so this is the part that parses the identifier, or Lexus, I should say. So I'll say get identifier. The first part skips spaces. Now we're gonna try to match a number. So if the input is a digit, then well, if it's a digit, it won't have gone into this block, so it will skip and go to this block. So if it's a digit or it's a dot, then we're gonna do this bit. We're gonna instantiate a num string, a string to be collecting the digits, and then at the end we're gonna use this stir to d to parse this string and convert it into an actual number. There's a do loop here. So we're gonna append the last char into this number string, and then we're gonna grab another char, another character from the input. We're gonna keep doing this until, or while I should say, we're gonna keep doing this while we're still getting digits or dots. I feel like there might be a problem with this code, because what if you get a digit and then a dot and then another digit and then another dot? That's not gonna work out. But whatever. This is a toy language. It doesn't have to be perfect. And then, so this part parses a, oh, we're not done. We need to call this stir to d function. And then return it as a number token. Okay. Okay, next we're gonna have some code to process comments. So again, if we're starting out with a comment, then it would have skipped this part, because a comment is started, by the way, a comment is started by this pound sign. So a comment in this programming language looks like this. So if the current character in the stream is a pound sign, then, well, it would have skipped this while loop because it's not a space, and it would have skipped this if statement because it's not an alpha character, and it would have skipped this if statement because it's not a digit. So it'll keep going until it encounters this if statement. And then here it's another do loop. So if we see a pound sign, we're actually gonna skip to the end of this line. We're gonna ignore all the characters after the pound sign. So that's what this while loop does. It's gonna keep reading char until, or while I should say, while we have not encountered the end of file, and while we have not encountered a new line character, and while we have not encountered a caret return character. Any result in us jumping out of this while loop. And also, if the last character is not the NF file, then we're gonna return get toke. Why are we recursively calling ourselves? Basically, if this while loop stopped in the file, but for one of the last two reasons, then we want to start looking for another token again, because we're just going to skip the comment and we don't care to return a comment as a token at all. We're just skipping that. So this function, this get toke function, recursively calls itself again here, so that we will get and then finally we have this code that says if last char is NF file, then we're going to return this NF file token, the toke NF file. And then finally, if all of these cases fall through, then we're just going to return let's see what's going on here. We're gonna save last char into this char so that we return it, but we're gonna get one more char. Why did we do that? I'm actually a little confused about that. So if we don't know anything, then this char it's setting up the last char for the next call to the get toke function, I believe. Is that true? No, I don't think that's true, because last char is a local variable. Why do we call get char again? So let me see if I can figure this out. So let's say this is the plus character. So it would have read last char. Oh, last char, initially it got set as the empty string. Oh, it never read. Well, while is space. Oh, but the first time it would be is space. So the first time get char is called. Last char would have been in the plus. Last char should be a plus, given my string. Let's say my string was plus 1 2. We should have had plus inside last char here. We're putting it into this char, and then we are getting a 1 into last char. Why are we doing that? That's actually quite surprising. Is that right? There might be a problem with this code. Interesting. Okay, well, if there's a problem with this code, we'll need to debug it later. And maybe there isn't. I just don't know what I'm doing. But so that's actually the end of this chapter. We have a Lexer, but we don't know if it's working actually. And I feel compelled to test this Lexer before we move on to the next chapter. So let me do that. So in C, the entry point of your program is always the main function. That's just a convention. If you write a main function, it will be the entry point of your program after you compile it. I'm going to call this get toke function basically until well, probably just forever. So I'm going to say while true. get toke, and we'll print out. I think I'll use C++ to print stuff out. In C++, the way you print things out is by using the IO stream. And IO stream has this thing called cout, which normally you, or I don't know if this should be the more normal way, but you can use cout like this, because cout is part of the standard namespace, so you can do standard : cout to reference it. But if you want to reference it just by the shorter name of cout, what you could do is say using namespace standard, and then everything that's in standard you can name them directly. So that's what I'm gonna do. And then here I'm gonna say got token, the toke, and then I'll do this NL to mean end the line. And let's run this and compile this program and run it, and then we'll test it. Okay, so because this is a C++ program, I'm going to use G++ to compile this program. You specify the output, you specify the program that it generates with this -o flag. I'm going to call it mylang.bin. This is a convention that I like to use, and I call the binary files a bin. So it compiled it, and now I have mylang.bin, which I can run. And I think the idea is I type some stuff into it, hit enter, and then this program is gonna run the get toke, or it's already run get toke actually. It's in the middle of this get char waiting for me to type in characters. So I'm gonna type in, say, a 3, and then it got toke -5. What does -5 mean? It's a number, so that works. That makes sense. If I type a multi-digit number, it still says get toke -5. That's really cool. What if it's an identifier, like, I don't know, Jimmy? Then we get a token -4. -4 corresponds to an identifier, so that seems correct. How to get a def? If I type def, then I get -2. That makes sense. Extern, and I get -3. I don't know how to get a file in this kind of user input scenario, so I'm not going to try that. But I think if I type in any other character, then I just get the ASCII code of that character. Yeah, this is the ASCII code. And you can verify that by going to the ASCIItable.com. So I talked a little bit about ASCII in one of the other the video I did with Huiqi last week. But ASCII is this table that gives a numeric characters that are on your keyboard, more or less. So if I type the character J, for example, well, J, that actually doesn't work because that got recognized as an identifier, but something that's not matched, like an equal sign, then it actually gives you the ASCII code of the equal sign character, which is 61. Yeah, that's what it printed. So this Lexer seems to work, and I guess that's a good start to this tutorial. Yeah, that's the end of chapter 1 of the LLVM tutorial. I'll see you in the next one.